So in the first row all the elements are zeros. If all the elements in a row or column are zeros, then the value of a determinant is equal to 0. Just adjoint of a, interchanging the diagonals for this. This is 4, 1, and changing the signs for the secondary diagonals, -2 and minus. So the intention is to convert all the elements in row 1 as A plus B plus C. Same. Find out the adjoint for matrix A and matrix B. Multiply adjoint of B into adjoint of A will give the final answer. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed regarding the properties of determinants and the problems based on properties of determinants for 4 marks. Today also I am going to take few more problems on properties of determinants and then adjoint and cofactor and inverse of a square matrix. Now let us come to the first problem. Now using properties we have to evaluate this. In the last class we solved a few problems like this. Let me solve few more problems which are very important for your annual 2022 examination. Okay. Now prove that the determinant A minus B, B minus C, C minus A, B minus C, C minus A, A minus B, again C minus A minus B, B minus C is equal to 0. Now without expansion we have to prove this is equal to 0. Now just convert this in such a way that it should reduce us to some properties so that you can straight away simplify using that property, right? Now you have to convert this in such a way that if all the elements in a row or column are zeros, if any 2 rows, 2 columns are zeros, if all the elements above, below the principal diagonal are zeros, so using the property we can straight away evaluate the answer. Now let us consider the LHS. LHS, this is LHS, A minus B, B minus C, C minus A, B minus C, C minus A minus B, again C minus A minus B and B minus C. Now taking, let us keep this R2, this is R1, row 1, this is row 2 and row 3. Now let us taking R1 dash is equal to R1 plus R2 plus R3. Convert this row, convert row 1 to R1 plus R2 plus R3. Otherwise you can take the column also. Convert column as C1 dash is equal to C1 plus C2 plus C3 as you wish. The intention, just convert any row or any column. For that add all the rows or all the columns. Now that is equal to, I will go to the next page, that's equal to. Now first, second and third column, third row are same, B minus C, B minus C, C minus A, again A minus B. This is second row and third row. What is third row? C minus A, C minus A, again A minus B, B minus C, A minus B, B minus C. Okay, this is second and third row. Now come to this, add this. First element of R1 plus first element of R2 plus first element. First element of row 1 is A minus B. First element of row 2 is B minus C. First element of row 3 is C minus A. Similarly, second element of row 1 is B minus C. Second element of row 2 is C minus A. Second element of row 3 is A minus B. Similarly, third element. So let us add first element of R1, R2 and R3. A minus B plus B minus C plus C minus A. So this is A minus B plus B minus C plus C minus C. Similarly, add second elements B minus C plus C minus A plus A minus B. B minus C plus C minus A plus A minus B. Similarly, for the last element, add this C minus A plus A minus B plus B minus C. C minus A plus A minus B plus B minus C. Now check what happens in the first row. Minus C plus C, minus A plus A and minus B plus B gets cancelled. 0, B minus C, C minus A as it is. Here also minus A, minus B plus B, minus C plus C gets cancelled. 0, C minus A minus B. Here minus A plus A, minus B plus B plus C minus C gets cancelled. 0, C minus A and A minus B. So in the first row all the elements are zeros. If all the elements in a row or column are zeros, then the value of a determinant is equal to 0. Now here this is equal to 0 RHS because the reason is all the elements all the elements in first row are zeros. So if all the elements in a row or column are zeros, then the value of a determinant is equal to 0. So since all the elements in first row are zeros, therefore the value of a determinant is equal to 0. That's it. This is how we are going to solve this determinant. Okay, let me explain once again. See, taking R1 dash is equal to R1 plus R2 plus R3. Row 2 and row 3 are same, B minus C, C minus A, A minus B as it is, C minus A minus B and B minus C are as it is. And changing the first row, add R1, first element of row 1 plus first element of row 2 plus first element of row 3. First element of row 1 is A minus B, first element of row 2 is B minus C, first element of row 3 is C minus A minus B plus B minus C plus C minus A. In this way we are going to add. So minus C plus C minus A plus B minus B gets cancelled. So first row will reduce us to 0. Since all the elements in first row are zeros, therefore the value of a determinant is equal to 0. That is your RHS. Hope you follow. You may expect this type of questions. Very easy and very simple problem. Okay, for 4 marks. Now let us come to the next problem. Now this is also a very important problem. You may expect this question. Prove that 1, 1, 1, A, B, C, A square, B square, C square. So there are two type of problems. 1, 1, 1, A, B, C, A square, B square, C square. The answer is A minus B, B minus C, C minus A. One more problem is there. 1, 1, 1, A, B, C, A cube, B cube, C cube. The answer is A minus B, B minus C, C minus A into A plus B plus C. So you may expect this or that question for the point of examination. Now let us take LHS. What is LHS here? LHS 1, 1, 1, A, B, C, A square, B square, C square. So convert this in such a way that all the elements above or below the principal diagonal are zeros. Now here this is, this is R1, R2 and R3. Now let us taking R2 dash is equal to R2 minus R1 and R3 dash is equal to R3 minus R2. Okay. Now let me expand this. So this can be written as, first row is same, 1 A square as it is. So this is R2 minus R1, this minus this, 1 minus 1 0, you will get B minus A, B square minus A square. R3 is dash is equal to R3 minus R2, this minus this, 1 minus 1 0, this is equal to C minus B into C square minus B square. See, R1 is same, 1 A square, R2 dash is equal to R2 minus R1, this minus this, 1 minus 1 0, B minus A, B square minus A square. R3 dash is equal to R3 minus R2, 1 minus 1 0, C minus B, C square minus B square. Okay, now if you observe carefully, this is B square minus A square is of the form A square minus B square. For A square minus B square, what is the formula we are going to write? A plus B into A minus B. So this can be written as, I'll go to the next page. This is equal to 1 0 0. This is same, A, B minus A and C minus B. Then here A square as it is, and this can be written as B minus A into B plus A. B minus A into B plus A. Another one is C minus B into C plus B. C minus B into C plus B. Now you can take the common factor. So here I can take B minus A common factor. Here C minus B is the common factor. So what we are going to get? 1 0 0. Here A into B minus A is gone, 1 1. Here A square as it is, B minus A is taken out. What is left over is B plus A. C minus B is taken out. What is left is C plus B. Now very simple. See, these two elements are 0. Convert this element as 0. So once if you convert this element as 0, then all the elements below the principal diagonal become 0. Then the value of determinant is product of principal diagonal elements. Now convert this as 0. Now again, taking R2 dash is equal to taking R3 dash. R3 dash is equal to R3 minus R2. This minus this. So B minus A into C minus B as it is. This is 1 A square. This is same 0 1 B plus A, and subtract this 0 minus 0 0, 1 minus 1 is 0, and what you will get here is C plus B minus B minus A. Minus B plus B gets cancelled, you will get C minus A. This becomes C minus A. Now see here, all the elements below the principal diagonal are zeros. So therefore, the value of a determinant is equal to product of principal diagonal elements. This can be written as b minus a into c minus b into 1 into c minus a. So now just convert b minus a. B minus a can also be written as minus a plus b or minus of a minus b. So this is minus 1 into a minus b. This can also be written as minus 1 into b minus c. This is 1 into c minus a, as it is c minus a. Now this can be written as minus into minus plus a minus b, b minus c and c minus a. So therefore, the required answer is a minus b into b minus c into c minus a. This is the required RHS. That's it. Very simple. Okay, listen to me here. So after converting, see here, just take LHS. This is very important problem. You may expect this for 2022 examination. So very important this is. So take LHS. This is LHS. Now taking R2 dash is equal to R2 minus R1 and R3 dash is equal to R3 minus R2. So A1 A square as it is. Now convert this 1 minus 1 0 b minus a b square minus a square 1 minus 1 0 c minus a c square minus a square. This can be written as a square minus b square is a plus b into a minus b. So b plus a into b minus a, c plus a into c minus b. So I will go to the next page. Here 1 0 0 a b minus a c minus a square b minus a b plus a c minus b c plus b. You can take common factor. What is the common factor here? B minus a is the common factor. Here c minus b is the common factor. So once b minus a and c minus b are taken out, 1 0 0 a 1 1 and a square, this is gone, b plus a into c plus a. Now what is the intention is to convert this 1 as 0. To convert 1 as 0, subtract this, 1 minus 1 gives 0. So for that we can take the operation, elementary operation, R3 dash is equal to R3 minus R2. So that is 1 a square 0 1 b plus as it is 0 minus 0 0 1 minus 1 0 c plus b minus c plus b minus b plus b cancel, you will get c minus a. Since all the elements below the principal diagonal are 0, therefore the value of determinant is 1 into c minus a, c minus a. So b minus a, c minus b into c minus a. B minus a can also be written as minus of a minus b. C minus b can also be written as minus of b minus c into c minus a as it is. Minus into minus becomes plus, a minus b, b minus c and c minus a. Therefore the required answer is a minus b into b minus c into c minus a, which is the required answer. That is the RHS. Hope you followed. Very important. Now let's come to the next type of problem. Now this is also a very important problem indeed. What is the problem given? Prove that minus a square ab ac ba minus b square bc ca cb minus c square minus a square minus b square minus c square is equal to 4 times a square b square c square. This is also a very simple and important problem indeed. Now just very simple here, let us take the common factors from all R1, R2, R3 and again from C1, C2, C3, simplify, you will get the answer. That's it. Okay, now let us take LHS. Now let me write LHS. LHS minus a square ba ca a into b minus b square cb a into c bc minus c square. Okay, this is LHS. Now taking a comma b comma c out from R1, R2 and R3. So taking a, b, c out from row 1, row 2 and row 3. So what is the row 1? This is row 1. R1, R2, R3. Now we are going to take a, b, c out. A, b, c outside from row 1. In row 1 we are going to take a out. So what is left is minus a is gone, b, a is gone, c. Okay. Similarly, in row 2, what is the common factor? We are going to take b. If we take b out, what is left here is a minus 1b and 1c is there. Okay. So we are taking b out from this. Now from row 3, take c common factor, a, b, c, c out, what is left is a, again b and 1c minus c. See here. So we are taking A, B, C out. A out from R1, B out from R2 and C R3 from R3 as common factors. Now again take A, B, C common factor from C1, C2 and C3. See, in column number 1 we have A common factor. In column 2 we have B common factor. In column 3 we have C common factor. We can take A, B and C again out from C1, C2 and C3. That's it. Now taking A comma B comma C out from C1, C2 and C3 again. So this reduces to, this is equal to ABC. Already we have taken. One more time we are taking ABC. So here A common factor from column 1, B common factor from column 2, C common factor from column 3. If you take A, then this becomes 1, minus 1, 1, 1, 1, minus 1, 1, 1, 1, minus 1. So what is the values? Minus 1, 1, 1, 1, minus 1, 1, 1, 1 and minus 1. Now let us simplify this. That's it. So this is equal to A into A is A square, B square, C square. Expand this plus, minus and plus. Minus 1 into 1, minus 1, minus 1 into this row and column is gone, minus 1, plus 1 into this is gone, 1 1s are 1, plus 1. So this is equal to A square, B square, C square. This is minus 1 into 0, minus 1 into minus 2, plus 1 into 2. So this is A square, B square, C square. This becomes 0, minus into minus plus, plus. So 2 plus 2 is equal to 4. So A square, B square, C square into 4. This can be written as 4A square, B square, C square, which is the required RHS. That's it. What is the answer we want to get? 4A square, B square, C square. 4A square, B square, C square. Very simple problem. Okay. That's it. See here. Let me explain once again. So taking A, B, C out from row 1, row 2, row 3. Then we will get minus A, B minus B, C and minus C. Again taking A, B, C out from C1, C2 and C3. In column number 1, column number 2, column number 3, we have A, B and C as common factor. So A, B, C are taken out. Then this becomes 1, minus 1, 1, 1, 1, minus 1, 1, 1, 1, minus 1. Expand this. If you expand, you will get this becomes 0. Minus 1 is minus 2. Minus into minus plus 2. 1 plus 1 is 2. 2 into 1 is 2. 2 plus 2 is equal to 4. So the required answer is 4 times A square, B square and C square. That's it. Okay. Very simple. Just take common factors. First ABC from R1, R2, R3 and again ABC from C1, C2, C3. Expand, you will get the answer. That's it. Okay. Now let us come to the next problem. Now this is also a very important problem indeed. So prove that A minus B minus C, 2A, 2B, B minus C minus A, 2B, 2C, 2C, C minus A. Here also diagonals are A minus B minus C, B minus C minus A, C minus A minus B. And this is 2A, 2B, 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 2C and 2C. What is the answer we want to get is A plus B plus C whole the cube. Okay, right. Now let us take LHS. What is LHS? LHS as it is A minus B minus C, 2B, 2C, then 2A, B minus C minus A, 2C, 2A, 2B, C minus A minus B. This is the LHS. Okay. Now taking R1 dash is equal to R1 plus R2 plus R3. Just add the corresponding elements of row 1, row 2 and row 3. That's it. So row 1, this is row 1, R1, R2, R3. Row 3, row 2 and row 3 are same. Let us write row 2 and row 3. 2B, 2C, again B minus C minus A, 2C as it is, 2B, C minus A minus B. Now we want to convert R1. So first element of R1 is A minus B minus C plus first element of row 2. First element of row 2 is 2B plus first element of row 3 is 2C. A minus B minus C plus 2B plus 2C. Similarly, these elements, that is 2A plus B minus C minus A plus 2C. Next, these elements, that is 2A plus 2B plus C minus A minus B. Okay. Now simplify this. If you simplify, what is the answer you are going to get here? So A as it is, 2B minus B is 1B, 2C minus C is 1C we will get. So this is equal to, that is A, 2B minus B is 1B, 2C plus 2C minus C is 1C. So I will get A plus B plus C. This is same 2B, 2C. Next, similarly, here also 2A minus A is 1A, B as it is, plus 2C minus C is 1C you will get. This is also A plus B plus C, and these two elements B minus C minus A and 2 times C as it is. Okay. Now let us come to the next. So here also 2A minus A is A, 2B minus B is B, again plus C as it is. So this is also A plus B plus C, and 2B, then C minus A minus B, C minus A minus B, right. So the intention is to convert all the elements in row 1 as A plus B plus C, same. See, all the elements in row 1 is same, so that you can easily remove A plus B plus C as the common factor. So here A plus B plus C is the common factor. What you will get? 1, 2B, 2C, 1, B minus C minus A, 2C, 1, 2B and C minus A minus B. Now simplify this. Okay, that's it. You will get the answer. Hope you followed this much. Taking R1 dash is equal to R1 plus R2 plus R3, A minus B minus C plus 2B plus 2C, 2A plus B minus C minus A plus 2C, 2A plus 2B plus C minus A minus B. So here A as it is, plus 2B minus B is B, plus 2C minus C is plus A plus B plus C, 2A minus A is 1A plus B as it is, plus 2C minus C is 1C, A plus B plus C, again 2A minus A is 1A, 2B minus B is 1B plus C, A plus B plus C, and the remaining are same. So we can take A plus B plus C common factor out, and the remaining things will remain the same. R2 and R3 are same. Okay. Now let us convert in such a way that all the elements above the principal diagonal are 0 or below the principal diagonal are 0. See, already elements here are 1 and 1. Convert all the elements above the principal diagonal as 0. So for this, let me taking C2 dash is equal to C2 minus C1 and C3 dash is equal to C3 minus C1, right. Now convert this. This is A plus B plus C as it is. We are converting. See, this is C1, C2 and C3 column. Column 1 is same. Column 1 is 1, 2B, 2C. C2 minus C1, these two. 1 minus 1, 0. B minus, I will write here, B minus C minus A minus 2B. So this can be as minus A minus B minus C, because B minus 2B is minus B. So this becomes minus A minus B minus C, 2C minus 2C, 0. Again C3 minus C was these two, convert these two. C3 minus C1, so 1 minus 1, 0, 2B minus B is 0, 2B minus 2B is 0, again C minus A minus B, C minus A minus B minus 2C, this is minus A minus B minus C. So this becomes minus A minus B minus C. See, all the elements above the principal diagonal are zeros. So once these elements are zeros, so the value of a determinant is equal to A plus B plus C into 1 into, you can take minus out, minus A plus B plus C into, again you can take minus out, A plus B plus C. Now what is this equal to? I will write here. So this is A plus B plus C, 1 into minus A plus B plus C, minus A plus B, minus into minus plus A plus B plus C into 1 into A plus B plus C into 1 is A plus B plus C whole the square. So this is equal to A plus B plus C into A plus B plus C whole square. This is equal to A plus B plus C whole the cube. This is the required RHS. That's it. Very simple. See here, minus into minus plus, 1 into A plus B plus C into A plus B plus C is A plus B plus C whole square. A plus B plus C whole square into A plus B plus C is A plus B plus C whole the cube. That's it. Very simple. See. So taking C2 dash is equal to C2 minus C1, this minus this, C3 dash is equal to C3 minus C1, this minus this. So these elements reduces to 0. Then All the elements above the principal diagonal are 0. Therefore, the value of determinant is equal to 1 into minus a minus b minus c minus a minus b minus c, that is minus out a plus b plus into a plus b plus c is a plus b plus c whole the square into a plus b plus c is a plus b plus c whole the cube. So, what is the answer we want to get? A plus b plus c whole cube. That's it. Okay. That's all regarding this type of problem. So, the properties and the problems based on properties are very, very important in the part E session. So, in part E, one 6-mark question and one 4-mark question. So, definitely you will get one question from this part for 4 marks and one more question from matrices, that is very just finding the inverse whenever the equation is given, right. So, these two type of problems are very, very important for 4 marks, right. Now, let us come to the next concept. I will go to the next concept. Now, the very important concept is the adjoint of a square matrix, so, and the inverse of a square matrix. So, finding the minus adjoint, then cofactors, right, minus, then cofactors, then adjoint and inverse all comes under the same category. So, let us take the adjoint and inverse. The adjoint of a square matrix A is equal to Aij of order m cross n is defined as the transpose of the cofactor matrix A. The transpose of the cofactor matrix obtained by A is called the adjoint and it is denoted as ADJ. The adjoint of A is denoted as C dash. So, the transpose of the cofactor matrix is called the adjoint. The transpose of the cofactor matrix is called the adjoint. Let us consider, for example, let A is equal to 2, 3, 4, 1, 4. This is the given matrix. So, find out the cofactor matrix, then the adjoint for this. So, the determinant of A is determinant 2, 3, 1, 4. So, the signs for this is plus, minus, minus and plus. Let me explain how to find the cofactors of a 2 rows, 2 column, then 3 rows and 3 column. Now, to find the cofactor here, the cofactor of first element 2, A11, cofactor of first element A11 is 2. This row and column is deleted, what is left over is 4. Then, the cofactor of second element 3. So, what is the sign? Sign is minus, delete the row and column containing 3. This column and row is gone, what is left is minus 1. Similarly, cofactor of 1 is equal to, what is the sign? Minus, this row and column is gone, you will get 3. And the cofactor of last element 4 is equal to, this row and column is gone, this is equal to 2. So, therefore, the cofactor matrix C is equal to what are the cofactors? That is 4, minus 1, minus 3 and 2. This is the cofactor. Now, according to definition, what is the adjoint? The transpose of this, C dash is equal to 4, minus 1, minus 3, 2. So, therefore, the adjoint of A is equal to C dash, this is 4, minus 3, minus 1 and 2. This is called the adjoint of a 2 rows, 2 column given matrix, right. This is how we are going to find the adjoint for 2 rows and 2 column whenever the question is given for 2 marks. Suppose if it is for 1 mark, if it is 1 marker question, straight away you can write the adjoint like this. For 1 marker, the adjoint straight away, the adjoint of A can be written as adjoint of A is equal to just interchanging the diagonals, interchange 2 and 4 as 4 comma 2 and changing the signs for the secondary diagonals, plus 3 becomes minus 3 and plus 1 becomes minus 1. See, adjoint of A is equal to 4, minus 3, minus 1 and 2. So, this is for 2 marks, this is for 1 mark. Okay, this is how we are going to. So, there are 2 methods to find the adjoint. This is by finding the cofactors and taking the cofactor matrix and transpose. Here, direct, just interchanging the diagonal elements and changing the signs for the secondary diagonal elements will give the adjoint of a given matrix. So, if this is divided by the determinant value, if it is divided by the determinant value, then we will get the inverse. So, A inverse is given by 1 over determinant of A into adjoint of A. That's it. This is how we are going to find the adjoint and inverse of a square matrix. Now, let us take few problems based on this. Now, let us come to this problem. If A is equal to 1, 2, 3, 4, show that this is very important property. A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I. Okay. Now, very important problem indeed. Let me find out first determinant of A. Determinant of A is equal to determinant 1, 2, 3, 4. This is equal to 1 4s are 4 minus 3 2s are 6. This is equal to minus 2. So, therefore, determinant of A is equal to minus 2. Now, find out the adjoint of A. Now, adjoint of A, as I told, this can be simplified very easily. Just adjoint of A, interchanging the diagonals for this. This is 4 1 and changing the signs for the secondary diagonals minus 2 and minus 3. Now, adjoint of A is equal to 4 minus 2 minus 3 and 1. Now, find out the left hand side LHS. LHS is A into adjoint of A. What is A? A is 1, 2, 3, 4 into adjoint of A is 4 minus 2 minus 1 and 3. Simplify this. So, if you simplify, what is the answer you are going to get? Minus 2 determinant of, say, here see, determinant of A into I. What is determinant of A? Minus 2, 1, 0, 0, 1. This is equal to minus 2, 0, 0, minus 2. You will get. Let me check. So, 1 into 4 is 4. First row, first column, second column, matrix multiplication. 1 4s are 4, minus 2 3s are 6. 1 2s are 2, plus 2 1s are 2. Then 3 4s are 12, minus 4 3s are 12. 3 2s are 6, minus 6, plus 4. So, this is equal to 4 minus 6 is minus 2, minus 2 minus 2 is 0, 12 minus 12 is 0, minus 6 plus 4 is minus 2. So, you can say, you can take minus 2 common factor, 1 0 0 1. This is nothing but minus 2 into I. What is minus 2? So, minus 2 into I is nothing but, what is minus 2? Minus 2 is the value of determinant of A into I. So, this is determinant of A into I. Let us represent this as equation number 1. Okay. See, if you multiply A into adjoint of A, you will get minus 2 0 0 minus 2, that is nothing but sorry, minus 2 out, 1 0 0 1, 1 0 0 1 is an identity matrix. So, you will get determinant of A into I. Now, on the other hand, let us come to the right hand side. What is the right hand side? On the right hand side, we have adjoint of A into A, RHS. That is adjoint of A into A. Let us simplify this. What is adjoint of A? Adjoint of A is 4 minus 2 minus 3, 1. 4 minus 2 minus 3 into 1 into A. A 1 2 3 4, 1 2 3 4. Simplify this same procedure. First row, first column, second column. So, 4 1s are 4, minus 2 3s are 6, 4 2s are 8, minus 2 4s are 8. Again 1 3s are 3, plus 1 3s are 3. Again 3 2s are 6, plus 4 1s are 4. This is equal to minus 2 0 0 minus 2. You can take minus 2 out, 1 0 0 1. Minus 2 is nothing but determinant of A. This is nothing but I, equation number 2. See, A into determinant of I, A into determinant of A into I, determinant of A into I. So, therefore, from 1 and 2 we can say that, therefore, from 1 and 2, we can say that A into adjoint of A is equal to adjoint of A into A is always equal to determinant of A into I. So, this is very important. That means A into adjoint of A is always equal to determinant of A into I, or adjoint of A into A is also equal to determinant of A into I. So, this is very important type of problem. Hope you followed. Okay. Now, let us come to the next problem, same type problem. What is the problem given? A and B are given, A 1 2 3 minus 1, B 3 2 1 1. Show that adjoint of AB is equal to adjoint of B into adjoint of A. So, first find out AB. First multiply the matrix AB. For that, find out the adjoint. Then find out the adjoint of A and adjoint B, then multiply adjoint of B into adjoint of A, you will get the answer. Okay. Let us come to the next problem. If A is equal to 1, 2, 3, minus 1 and B is equal to 3, 2, 1, 1, show that adjoint of AB is equal to adjoint of B into adjoint of A. This is also an important type problem. Here, just find out AB first, multiply AB, matrix A and B, find out the adjoint for that AB, then find out the adjoint for matrix A and matrix B, multiply adjoint of B into adjoint of A will give the final answer. Now, let us come to the first part, multiply AB. Now, AB matrix multiplication 1, 2, 3, minus 1 into 3, 2, 1, 1. So, first row, first column, second column. This is 1 3s are 3, plus 2 1s are 2, 1 2s are 2, plus 2 1s are 2, 3 3s are 9, minus 1. Again, second row, second column, 3 2s are 6, minus 1. So, this is equal to 5, 4 and 9 minus 1 is 8 and 5. Now, for this, just find out the adjoint. Adjoint of this is AB. Adjoint of AB, determinant of AB is equal to determinant 5, 4, 8, 5. The adjoint of matrix AB can be written as I told, interchange the diagonals, this 5 and 5 remains the same, and changing the signs, minus 4 and minus 8. Let us represent this as equation number 1. Okay. Now, adjoint of AB is equal to this. Now, similarly, find out the adjoint of A. Now, adjoint of A is equal to, straight away I will write the adjoint of A. Interchanging the diagonals, 1 minus 1 can be written as minus 1 and plus 1, and plus 2 minus 2 can minus 2 and minus 3. So, see, just interchange the diagonals, plus 1 and minus 1 becomes minus 1 and plus 1, minus 2 and minus 3. Similarly, for B, adjoint of B. Adjoint of B. What is adjoint of B? Interchange the diagonals. 1, 3. 3, 1 becomes 1, 3 and plus 2 becomes minus 2 and minus 1. Okay, these are the adjoints of A and B. Now, on the RHS, let us take this RHS. Now, what is RHS? RHS is adjoint of B into adjoint of A. Adjoint of B into adjoint of A. Now, what is adjoint of B? Adjoint of B is 1 minus 2, 1, minus 2, minus 1, 3. Then, adjoint of A, minus 1, minus 2, minus 3, 1. Minus 1, minus 2, minus 3, 1. This is adjoint of A and adjoint of B. Let me check. Adjoint of B, 1 minus 1, 1 minus 1, minus 2, 3. Adjoint of A is minus 1, minus 3, minus 1, minus 3, minus 2 and 1. Now, multiply this matrix. First row, first column, second column. This is 1 1s are 1, minus 1, minus into minus plus, 2 3s are 6. 1 1s are 1, minus 2, minus 2. Again, 1 1s are 1, minus into minus plus, minus 3 3s are 9. Minus 1 into 2 is plus 2, plus 3 1s are 3. So, this is equal to 6 minus 5, 1 is 5, minus 2 is minus 4, 1 minus 9 is minus 8, 2 plus 5, 2 plus 3 is 5. So, 5 minus 4 minus 8 minus 5. This is equation number 2. Now, verify from 1 and 2. Therefore, from 1 and 2, see from 1 and 2, what is LHS we have? In the LHS we have adjoint of AB. This is 5 minus 4 minus 8 5. 5 minus 4 minus 8 5. See 5 minus 4 minus 8 5 in the right hand side also. So, therefore, from 1 and 2 we can say that adjoint of AB is also equal to adjoint of B into adjoint of A. This is the final answer. So, therefore, adjoint of AB is equal to adjoint of B into adjoint of A, that is 5 minus 4 minus 8 5. 5 minus 4 minus 8 5. This is how we are going to verify. This is also important. Sometimes you may expect this for a 5 marks or 4 marks, 5 marks questions. Okay. Now, let us come to the next concept. The very important concept is inverse adjoint of a square matrix. So, in which there is one important concept. So, if A is a square matrix of order n, then determinant of adjoint of A is equal to determinant of A to the power of n minus 1, where n is the order of a matrix. Suppose in case of 2 rows 2 column, determinant of adjoint of a matrix is always equal to determinant of A to the power of 2 minus 1 is determinant A. Similarly, for the matrix of order 3 rows 3 column, determinant of adjoint of A is equal to determinant of A to the power of 3 minus 1 means determinant A square. This type of problems we have solved this type of problems in 1 marker questions. Let me take one more example. Let us take an example. If A is equal to 1, 2, 3, 4, then let us find out the determinant of A. Determinant of A is 1, 2, 3, 4. This is equal to 4 minus 6 is minus 2. Now, if I take the adjoint of this, adjoint of A is equal to, what is the adjoint? Interchanging the diagonals, 4, 1, and this is minus 2 and minus 3. If I take the determinant of adjoint of this, determinant of adjoint is equal to 4 ones are 4, again minus into minus, plus into minus, minus, that is equal to 6. This is also equal to minus 2. See here. So, what is the determinant of adjoint of A? Adjoint of A and determinant of A are minus 2 is equal to minus 2 for 2 rows 2 column. That means adjoint of A is also equal to determinant of A for 2 rows and 2 column. For 3 rows and 3 column, it will becomes A square. Okay, this is very important concept. Now, let us come to the next one. If A is a square matrix, if A is a square matrix and it is invertible, A is a square matrix, A is said to be invertible if and only if it is a non-singular matrix. So, you know what is singular and non-singular? If determinant of A is equal to 0, then it is called as a singular matrix. If determinant A is equal to 0, singular. If determinant of A is not equal to 0, then it is called as a non-singular matrix. So, here determinant of A should not be equal to 0. For a non-singular matrix, the inverse exists. A inverse is given by 1 over determinant of A into adjoint of A, or A inverse is equal to adjoint of A divided by determinant A. Now, let us take a small example. Find the inverse. So, to find the inverse of this matrix, let us find the inverse. So, find out the determinant of A. Determinant of A is equal to determinant 3, 2, 1, minus 1. This is equal to minus 3, minus 2, that is equal to minus 5. Now, find out the adjoint of this. As I told, the adjoint of this is given by adjoint of A is equal to interchanging the diagonals, and this becomes minus 1 and 3, and changing the signs for the secondary diagonals, minus 1, minus 2, minus 1 and 3. Now, what is the formula for inverse? Therefore, A inverse is equal to 1 over determinant A, 1 over minus 5 into minus 1, minus 1, minus 2 and 3. This is the inverse for the matrix. So, A inverse is equal to minus 1 over 5 into minus 1, minus 2, minus 1 and 3 is the inverse for the given matrix. That is it. So, just find out the determinant of A. Determinant of A is 3, 2, 1, minus 1, 3 ones are 3, minus 2, minus 5. Adjoint of A is nothing but interchanging the diagonal elements, minus 3 and plus 1, and changing the signs for this, minus 2 and minus 1. Substitute here. So, A inverse is equal to minus 1 over 5 times. So, A inverse is equal to minus 1 over 5 times minus 1, minus 2, minus 1 and 3. This is the inverse of the given matrix. That is it for 2 marks. Okay. Now, let us take one more problem. Find the inverse of this matrix B. Now, find out the determinant of B. Determinant of B is minus 1, 5, 0, minus 2. This is equal to 2 ones are 2, minus 0 is 2. Determinant of B is equal to 2. It is a non-singular matrix. Inverse exists. So, A, find out the adjoint of B. Adjoint of B is equal to interchange the diagonal elements, minus 2, minus 1 and minus 5 and 0. Now, therefore, B inverse is equal to 1 over determinant of B into adjoint of B, that is nothing but 1 over 2 into minus 2, minus 5, 0 and minus 1. This is the inverse for the given matrix. Okay. Now, finally, let us come to the last problem. So, what is given if A is equal to 2, 3, 1, minus 4, B, 1, minus 2, minus 1, 3. Verify that AB whole inverse is equal to B inverse A inverse. This is called the reversal law of inverses. Okay, let me find out A inverse first. So, determinant of A is equal to 2, 3, 1, minus 4. This is minus 8, minus 3, minus 11. So therefore, adjoint of A is equal to, just interchange the diagonal elements, minus 4, 2, minus 3, minus 1. So therefore, A inverse is equal to 1 over determinant A, 1 over 11 into minus 4, minus 3, minus 1 and 2. Similarly, come to the matrix B. So determinant of B is equal to 1, minus 2, minus 1 and 3. Simplify this, 3, 1s are 3, minus into minus, plus into minus minus. This is 3 minus 1 is equal to 2. So now find out the adjoint of B. Adjoint of B is equal to, interchanging the diagonal elements, 3, 1, this becomes plus 2 and plus 1. Now therefore, B inverse is equal to 1 over determinant of B, 1 over 2 into 3, 2, 1, 1. So these are the values of A inverse and B inverse. Now let us multiply AB. First find out AB, then we will go for a B inverse, A inverse. Now AB is equal to, matrix determinant AB is equal to 2, 3, 1 minus 4 into 1 minus 2, then minus 1, 3. Simplify this. So this is 2 1s are 2, 3 1s are 3, 2 2s are 4, plus 3 3s are 9, 1 1s are 1, minus into minus plus 4, again 1 2s are 2, minus 4 3s are 12. So this is minus 1, 5, 5 and minus 14. So the determinant of this, determinant of AB is equal to minus into minus plus 14 minus 14, my 5 5s are 25, this is equal to minus 11. So therefore, find out the cofactor, the adjoint of AB is equal to, adjoint of AB is nothing but minus 14, minus 1, minus 5 and minus 5. So therefore, AB whole inverse, AB inverse is equal to minus 1 over 11 into minus 14, minus 5, minus 5 and minus 1. Let us call it as equation number 1. Now let us come to the right hand side. What is RHS? B inverse, A inverse. B inverse into A inverse. Now just multiply this. Determinant of B is equal to 1 into 3 is 3, minus into minus plus, this is equal to 1. So therefore, adjoint of B is equal to, adjoint of B is nothing but the transpose of this, 3, 1, plus 2 and plus 1. Okay. Now therefore, B inverse is equal to 1 over 1 into 3, 2, 1, 1. Right. Now let us come to the RHS. B inverse, A inverse. What is B inverse? 1 by 1 into 3, 2, 1, 1 into A inverse. What is A inverse? A inverse is minus 1 over 11 into minus 4, minus 3, minus 1, 2. Okay, multiply this. So this is minus 1 over 11 into 3 4s are 12, minus 2, 3 3s are 9, minus 9, plus 4, again 1 4s are 4, minus 1, 1 3s are 3, plus 2. So this is minus 1 over 11 into minus 14, minus 5 and minus 1. This is equation number 2. See the equation 1 and 2. Minus 1 by 11 into minus 4, minus 5, minus 1. So therefore, from 1 and 2, we can say that, what is the answer we are verify? AB whole inverse is equal to B inverse A inverse. This is called a reversal of inverses. Hope you follow. Find out the inverse for A, inverse of B, and then find out AB and find out the inverse. Verify AB whole inverse is equal to B inverse, A inverse, you are going to get. That's all regarding this session. Let us meet with a different concept in the next class. Thank you very much.